When I heard about people still believing in a flat Earth, at first I thought it was a joke, and that everyone else felt the same way. But it seems that more and more people are sucked into this madness by some careful leaders who promise the truth and then immediately change the subject when their own tests work against them. And I say madness because the topic of this video is gravity, or better yet, the lack of it. So this individual made a video to explain how there's no gravity. He begins by presenting the density formula 3 times, and then he thinks he proves the absence of gravity because an egg floats in salted water.
But we can see here with these 2 jugs of water that one is more buoyant than the other. We have the same amount of water, but the jug on the right has more buoyant water because it's more dense with salt. We just made the water denser. We just have a difference in the relative density, not because of any force created by the mass of the Earth, but more to do with the density of the egg's immediate surroundings. And so now we make the water less dense by adding some of the non-salted water. We have an egg floating about at an equilibrium. But if you believe that we live on a globe and stick to it because of the force of gravity, then you have to say that we now have an opposing force.
So equilibrium and opposing force, even though he says it sarcastically, let's see what that means. So we bring in an object and we drop it on the table. It will stay there at an equilibrium just as he said, and it won't go anywhere unless we apply a force. In this case, it will roll over and fall off. But if we apply an opposing force, the object stops, even though there are 2 competing forces acting on it. The object will be at an equilibrium. Now, if this is true, then why should this be so crazy? Isn't this really similar to the egg in the water jug? Nonetheless, he goes on.
And we have the pressure of the water acting on the egg. However, if you look at the egg, you see that it is not suffering from being squashed.
Okay, if you think there's no water pressure, I recommend you take a deep dive into a lake or any body of water without a suit and let me know how that works out.
So here we see the egg is in fact weightless.
I like how you stopped there for a second before saying it was weightless, almost as if you weren't sure if that was true. Well, it's really not, and you can check that with a scale. The jug with the egg will be heavier. But let's have a closer look as to why the egg floats or sinks. Here we have a ball, and we know that it falls on the ground. As shown previously, it will only move when a force acts on it. And since it's going down, it's reasonable to assume the direction of said force is downwards. Let's call this force the downwards force. Now, flat Earth believers say it depends on the density of the object. So far so good. But if we think about bottles of water, we know that a 5-liter bottle feels heavier than a 1-liter bottle. So then the downwards force also depends on the volume of the object. As he showed us in the beginning, density times volume is mass, so the downwards force appears to depend on the mass of the object. Let's add some water to our example and see what happens. We notice that one object sinks and the other floats. This can only be true if the downwards force is overcome by an opposing force. Let's call it the buoyancy force. Now, we all agreed that the red object sank because its density is larger than the density of water, while the density of the blue object is smaller, so it floats. By similar reasoning to the previous case, we conclude the buoyancy force is proportional to the density of the liquid and the volume of the displaced liquid, which is the volume of the object. This means that the buoyancy force is proportional to the mass of the displaced liquid.
So the question is, where did the gravity go?
Well, let's try to answer this question. A spring at rest will stay at rest, just like the other objects, unless a force acts on it. To stretch it, we must pull with a downward force. When we let go, the spring bounces back to its initial state. Now, when we connect the object to the spring and let go, the same thing happens, so there is a force pulling down on the spring. After a certain elongation of the spring, the whole system is at equilibrium, with the downward force pulling down and the elastic force trying to bring the spring back into its initial state. Since it is equilibrium, the forces are of equal strength. Now, the greater the elongation, the greater the elastic force, so the latter is proportional to the elongation. As before, the downwards force is proportional to the mass of the object. Now let's do the following experiment. We use two identical springs. On the first one, we hang one object of mass m, and on the second, two of the same objects, so the total mass will be 2 times m. If we now measure the two elongations, we see that the second is twice as long as the first. Okay, if this is true, since the elastic force was proportional to the elongation, then this relation is true, but the elastic force at equilibrium is equal to the downwards force, so then this relation is valid. Then it means there's a linear dependence between the mass and the downwards force, which in turn means that the latter is equal to the mass times a constant. Now where have I seen that before? Oh, I know, gravity equals mass times the gravitational constant.
So the question is, where did the gravity go?
Well, it was with us the whole time, we just nicknamed it the downwards force. However, I have a question for you. How can you explain this with your model? As you said, the egg must be weightless. So where does the extra weight on the right side of the scale come from then?